Hello, guys. I hope you're doing well. I hope all is auspicious. We are going to continue with our second part of solving these kinds of weird equations with weird indices and weird roots and all that kind of good stuff. So let's get into it. We've got 5 plus the square root of y all to the power of a fourth is equal to 3. Well, we're going to undo this power of a fourth. And we can think about it by raising both sides to the power of 4. Why do we do that? Well, we have 2 plus the square root of y to the power of a quarter. If you raise that to the power of 4, that's of course going to equal 3 to the power of 4. We've done the same thing to both sides. On the left-hand side, the 4, remember using the index law, that the 4 multiplies with a quarter to make 1. So that becomes 2 plus the square root of y to the power of 1. Which is equal to 3 to the power of 4. But anything to the power of 1 is just itself. So we have 2 plus the square root of y is equal to 3 to the power of 4, which is 81. Okay, hopefully that made sense. And then take away 2 from both sides. We have the square root of y is equal to 81 take away 2, which is 79. Then squaring both sides, we have y is equal to 79 squared. Okay, so therefore y is equal to, let me just multiply. So we have 79 squared, just checking my calculator because doing this in my head is 6241. So we have that y is equal to 6,241. Let's keep going, guys. Here's the next kind of question that looks a bit wow. Right, so we have x to the power of 2/3 equals 2 to the power of 7 over 9. Well, first of all, mixed numbers are just a big no-no. No, 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 no. We are not going to tolerate mixed numbers. Please. Right. So we have x to the power of 2/3 is equal to, let's convert this into a top-heavy fraction or an improper fraction or whatever else you guys like to call it. So 2 times 9 is 18, plus 7 is 25. Over 9. That is much nicer, guys. Much, much, much nicer. So what we're going to do here is raise both the left-hand side and the right-hand side to the power of 3 over 2. Okay, why am I raising it to the power of 3 over 2? It's the reciprocal of 2/3. Okay, just like with the previous example. If I now multiply these indices, let me just write this as well. To the power of 3 over 2. If I'm multiplying these two fractions, I end up getting 6 over 6, which is 1. So I'm left with x to the power of 1 is equal to this thing here. 25 over 9 to the power of 3 over 2. Okay, so x to the power of 1 is just the same thing as x. So I can say that x is equal to 25 over 9 to the power of 3 over 2. Right, this 3 over 2 means I'm taking the square root of these numbers and then I'm cubing the answer. So conveniently, 25 and 9 are square numbers. So if I take the square root of 25, I get 5. If I take the cube root of 9, the square root of 9, then I get 3. Then I'm cubing that result. Okay, cubing that result. And that's going to give me, well, 5 cubed is going to give me 125. And then 3 cubed is going to give me 27. So I have that x is equal to 125 over 27. Alrighty. And also, I would like to know if people can comment as to why I didn't consider the negative square root when I square rooted. Why did I not need to do that? Let me know in the comments. Okay, next one, x to the power of 3 over 2 equals 64 over 729. So a similar example to what was above. We're going to raise both sides to the power of 2/3. Okay, so that equals 64 over 729 to the power of 2/3. So on the left-hand side, it cancels. The 3 over 2 times 2 over 3 gives you 1, so that's just x. Then here we cube root both sides because the 3 is at the bottom. So that's going to both the top and bottom. So we get 4 over 9, the cube root of 64 and the cube root of 7.